All right, guys, we have reached the end of chapter 3. So what I'm gonna do is I'm gonna make these videos as like summary videos in this week that we're gonna be preparing for our big benchmark. So we're gonna do two of these. All right. The first one will cover these first two things: rational exponents, how they're related to roots, solving equations, and we'll talk about function notation. Then tomorrow I'll have a video and some practice for composite functions and inverse functions. And then the goal will be that at the end of the week, we'll feel ready for our assessment. We'll mix in a day where we'll do a work day on our project, which is all about sort of compiling our best work from the past couple weeks and putting together a great, sort of like evidence of proficiency type assessment. All right, but let's get right into it. All right, let's talk about rational exponents. Okay, basically what we've learned is, if I see an exponent that's a fraction, I can always rewrite it like this or like this. I like that this uh, diagram tells you, look, it's not to say that you can't do it the other way, where you take the a and raise it to the power of m first. You'll get the same answer. It's just that this will make the number underneath here absolutely enormous. And potentially something that you can't in your head sort of piece it together. Whereas if you do this, it's likely that you'll be able to figure this out on your own and then raise it to whatever power. So here's a great example: 16 to the power 3 over 4. I could have taken 16 and cubed it first, but I doubt that any of you guys know off the top of your head what the fourth root of 16 cubed is. But I think I can figure out the fourth root of 16. It's 2, because 2 times 2 times 2 times 2 is 16. Okay, so the fourth root of 2 is 2. 2 cubed is 8. I will say it's actually wrong here. I mean, it's 8 or it's uh, -8, because anytime you're taking an even root of something, you get two answers. Anytime you're taking an even root of something, you get two answers. It's true of square roots, it's true of fourth root, sixth root, 10th root, 20th root, whatever. All right. So some of the problems that you'll be expected to do on this benchmark will include being able to simply go from here to, oh, this is the cube root of 6b to the fifth. All right. That's a question you're expected to be able to figure out. Right. Same as doing the reverse, which is going to require in situations like this, you go, oh, wait. If I don't see anything here, it implies a square root, right? So this is 5m to the power of 3 over 2. The root stays on the bottom. It's like, oh, yeah, that's so easy, Mr. Carter. I remember doing that. What a breeze. Yeah, well, do you remember these ones? Right? Are you skilled at applying exponent rules from the chapter before this? Right? Are you able to go, oh, that's okay. I got to worry about this. And then 2 times 3 over 2 just becomes 6 over 2. This, you guys, it's not to say that you couldn't take it and rewrite it as, oh, it's the square root of 25 cubed. It's not to say that that's not the case. Of course, you could do this, but also just put this in your calculator. 25 to the power 3 over 2. You can just do that. Square root of 25 is 5 or -5. 5 cubed is 125. So 125 to, times x to the third, right? 6 over 2 simplifies. Okay, yeah, all right. I forgot about those, Mr. Carr. Like, that's a little bit harder. Yeah, well, how about these? How about these? All right. The first thing that you want to be thinking of, I'm hoping that your approach to this video is maybe like to pause me and then try this a little yourself, and then you can hit play and you'll just have me going through the rest of it, right? I would challenge you to see how well you can do this on your own. The first thing you want to be thinking of is, okay, this is still an algebra problem. I'm still just trying to solve for b. All right. So why don't I start by doing the things that I've been doing my whole life for mathematics, right? If I do something to one side, I do it to the other. Okay, divide by -3. And now I wind up here. B to the power of 4/5 equals 16. And this is where people forget those exponent rules. Guys, don't ever forget that math is all about manipulation. I want to manipulate this to be what I want it to be. Because 4 times 5 is 20. 5 times 4 is 20. So when I do this, what's happening is that I'm getting b to the power of 20 over 20. And that is pointless, right? I don't need to worry about b to the power of 20 over 20. That is just b to the first. So what is my b value equal to? 16 to the power of 5 over 4. And again, I say, put this in your calculator. Try to remember. Oh, I'm going to be doing an even root, right? This is the fourth root of 16, which we covered earlier in this slideshow, is 2. Or -2. So you got to be careful. There's going to be two answers. Okay, 2 to the 5th is 32. But that, because I took the fourth root of it, couldn't it also be -32? And that's what we're going to see, right? When you put this in your calculator, it's just going to give you one answer. So just be careful. Be a critical thinker who's already thinking ahead of that fact. So there you go. I'll still put it in my calculator, but I'll just know my calculator's going to tell me 32, but I'm smart enough to know the other answer is just the negative version of whatever that is. All right, let's talk about function notation. All right, this was a huge piece of this chapter. I often said this is, putting on your grown-up pants here, okay? Being an adult. We don't really use y equals anymore. We use functions. So it's good to get comfortable with this stuff, especially for like the SATs. It's good to keep this stuff in mind, right? So f, in this case, just the name of the function, right, for a function, but it could be g. You could do anything. I suppose you could do x of x, but we have 26 letters in the alphabet, so I'd ask that you probably don't do that, right? If we can pick other choices, we should. This is going to be whatever the input is. This I like to call the rule. It tells you what the function does. Okay, so this function's always doubling things. It's always doubling things. All right, and we've learned about function operations. We can add functions together. We can subtract functions. We can multiply functions, and we can divide functions. This slide is a great slide to like screenshot, put in your notes, whatever. Gives you great examples of what it takes to write new rules, right? F minus g of x. What it's saying is, here's function f, 4x minus 5. Here's function g, 2x. If you made a new function by combining these through subtraction, where this minus this, 4x minus 5 minus 2x, 4x minus 2x is 2x, combining my like terms. So this new function, f minus g of x, is really just 2x minus 5. That's really what's happening. I could say, you know what, I'm gonna call this h of x, and h of x is what happens when you subtract. So if you're like, why would we do this? So you can make new functions out of, old functions. You can take two functions, put them together, and create something new. Something new is happening here. All right. So for the types of practice problems I need you to be able to do, are you skilled in the art of evaluating? Can you take, okay, I know what this means. I replaced this x with a -9, so you know what? I'll replace that one. Okay, -27 plus 1 is -26, and I'm done. Are you able to write new rules? It's tough. I think people do better when there's a number in there. They don't like these, and I don't blame them. I don't blame them. Right? But what I'm asking you to do is think about this equal sign. What does an equal sign mean? It means you can substitute. If h of n is equal to this, and when I see h of n, why don't I just substitute in that? When I see g of n, why don't I just substitute in this? Right? So let's distribute the negative. 2n minus 1 minus 4n plus 3. Right? Don't forget to distribute it this way. So 2n minus 4n, I get negative 2n. Negative 1 plus 3 is plus 2. Okay, so that's a new function that I created by subtracting those functions. Great. Multiplying. This is where old skills pop up again. You want me to take g and multiply it by h? I wonder if I should use the table method. Yes, you should. Right? 4x, 3, x squared, 2x. Okay, this becomes 4x cubed. This becomes 3x squared. This becomes 8x squared. This becomes 6x. Combine my like terms, and that's how I'll get this. Are you able to not have to worry about writing a new rule, but saying, I want you to take g of 2 and multiply it by h of 2. So there are two schools of thought. You could be like, well, why don't I just see what happens when I multiply these together, and then whatever I get from putting those together, then I'll just plug a 2 into that. Or you could just dive right into like, I'll just get started. I'll just figure out, what is g of 2? It's going to be 4 times 2 plus 5. That's 8 plus 5. It's 13. Okay. What is h of 2? It's going to be 2 squared plus 2 times 2. So that's 4 plus 4. So 8. So when I do g of 2, I can now say I can replace that with 13. I can replace h of 2 with 8. 104? Did I just do my math right? 8 times 10 is 80. 8 times 3 is 24. Add together. Yeah, 104. Nice. Right? And that takes you through what I expect you guys to be able to do for the first half of the chapter. The assignment that goes with this, it'll be full of lots of questions. You don't have to do all of them. The point is to more just have a large enough piece that you feel like you can practice what you need the most practice on. And hopefully this video helps you guys study.